If you stand in the shadow of Mount Kilimanjaro at sunrise, it looks like a colossal, purple giant towering over the African savanna. But wait until the clock strikes 12. If you look up, the mountain is gone. It hasn't moved, and there isn't a cloud in sight. It has simply dissolved into the blue. This is the noon vanishing phenomenon, and it's a brilliant example of how our brains and the atmosphere work together to delete entire landscapes.
Behind every moment lies a scientific wonder. I'm Kale, and welcome to SciCurios, where curiosity meets science.
The first culprit is Rayleigh scattering. You know why the sky is blue. Air molecules scatter blue light more than any other color. At noon, when the sun is directly overhead, the atmosphere is saturated with this scattered blue light. This creates a veil of brightness between you and the mountain. But the real secret lies in shadows. We perceive 3D shapes because of contrast, the difference between the bright parts of a mountain and the dark shadows in its valleys. At noon, especially in the tropics, the sun is at its zenith. It's hitting the mountain from directly above. Shadows disappear into the crevices, and the mountain loses its texture. Without shadows to define its edges, the mountain looks as flat as a postcard. Then, there's the luminance match. As the midday sun gets brighter, the amount of light reflecting off the mountain's snow or light-colored rock begins to perfectly match the brightness of the hazy sky behind it. In physics, we call this a loss of Weber contrast. When the object and the background have the same brightness and color, your brain essentially hits the delete key. It can't tell where the rock ends and the sky begins. Finally, there's aerosol optical depth. In many tropical regions where these mountains are found, the air is filled with microscopic water droplets or dust. This creates airlight, light reflected by the air itself, which acts like a white fog. By noon, the heat has lifted enough moisture to thicken this veil, completing the vanishing act. It's not until the sun begins to drop and the shadows return that the mountain rematerializes for its sunset encore. It's a powerful reminder that we don't see the world exactly as it is. We see it through a filter of light, air, and timing. If you were a photographer, would you prefer the easy-to-see mountain at sunrise or the challenge of capturing the invisible peak at noon? Let me know in the comments.
Science is everywhere if you just know where to look. Thanks for watching SciCurious. Until next time.